Hello, everyone. My name is Haifeng, and I'm from the Lab of Interdisciplinary Spatial Analysis and in the Department of Land Economy, University of Cambridge. Today, I'm going to talk about delineating urban functional use from point of interest data with Doc2 vector model. First of all, I have to apologize. At around 12 o'clock, there is the fire alarm testing, so sorry about that noise. uh, so before when we talk about urban functionaries, many geographers or urban planners might be quite familiar with another concept, land use and land cover. For land use and land cover, it focus on the human impact on the physical environment, and compare with the urban functionaries, it focuses at the macro level, and for urban functionaries, it more focus on the urban activities and the use of buildings at a very micro level. So why should we understand urban functional use? This is because it can provide not only the geospatial features for modeling and simulation in the cities, but also help to detect urban problem, evaluate planning policies, and better support the policy makings, especially in those highly urbanized and densely populated metropolitan areas. So the urban function and the form has been studied in this in our domain for quite a long time. But I would like to talk talk a little about the contemporary background of this topic. And nowadays, the city has been regarded as a complex system. And based on the complexity theory, we would like to understand the urban patterns from a bottom up. And because of the emergence of the big data, the new type of data, especially those disaggregated data that we can collect from the social media data and the point of interest and trajectory data and those cortisol data, um, people can understand the can explore the urban patterns from bottom up. In terms of the topic, in the urban form and function, a group of researchers explored this urban form and function with that cortisol data, and you can find uh, uh, in this highly cited paper talking about that. So today, I'm going to use the point of interest data to delineate the urban functional use. For those not familiar with point of interest data, POI data in the context of the cities, it refers to the location points such as commercial properties, public spaces, and transportation facility, etc. And you can find those POI data on those location-based surveys on Google Map, OpenStreetMap, Foursquare, Yelps, and you can also find them on the social media platforms because they have deeply integrated with those location-based surveys. So why it is possible to explore this, to delineate the urban functional use with that point of interest data? Because there's a point of interest data with different classes distributed variously in our urban areas, and this spatial variation reflects to some extent reflects the preference of urban activities, and this can indicate the patterns of urban function use at a larger level, at a larger scale. So this is why we can use point of interest data to delineate urban function use. So in processing the point of interest data, we have to do some problem. For instance, those kind of data sets is quite large, and considering the classes of the POIs, might be hundreds and thousands types of POIs. It also has this problem with the dimensionality. So to mine those POI datasets, researchers start to use some technologies from techniques from the natural language processing. This is because we found that the similarity between POI datasets and those natural languages. I will talk about that later in the case study. For those techniques we use in mining POI data, the data sets, a previous study used this frequent-based method, and recently people switched to the neural word embeddings to explore those POI data sets. So before I talk about the neural word embedding method, I want to talk about the drawback of this frequent-based method. Some methods, for instance, the bag of words, term frequency, and the latent direct allocation. This kind of methods focus on the co-occurrence between the word. It looks so it ignores the syntax between words, which means it doesn't consider the order between the words. It just calculate the co-occurrence or the distribution of the words in the bag of words in that document. So when we apply this kind of frequent-based method to the POI's mining, it basically ignores the spatial relationship between the POI's points, which means it's a problematic because it completely abandon the first law of geography. So this is why we need to use the neural word embedding to fill that gap. What is neural word embedding? Basically, it uses a two-layer neural network. If you listen the presentation from Professor Chen Tao yesterday, you have a brief idea about the neural network. It's not this neural word embedding is not a deep learning. It's just a two-layer neural network. In 2017, Yao integrated the word-to-vector models with point of interest data. In this model, you can see that in this two-layer neural network, it's vectorizing the point of vectorizing those input data with a fixed length, fixed length vector representation, which means if we input the POI classes in the input layer, and we can get a vector representations for those POI classes. One thing which I should mention is that the hypothesis behind this model is that is the distribution hypothesis. It means that a similar distribution have similar meanings for words in the natural language. So if we apply this to the POI data mining, the distribution hypothesis should be changed to that the similar the similar distribution of POIs have the similar functions. So to explain better about this model, you can see that the input layer here, we need to tokenize the sentence, the same as this line, the cat set up at mat. So basically, if we use word to vector model to this natural languages processing works, basically we want to predict the central word by its surrounding word, which means we have to set a window size so we can use those. For instance, we set a window of size at 2. We need to include the 2 words before the central word and the 2 words after the central words. And in the word to vector model, we can predict the central word. So during that training process, we will eventually get a vector for each word. But you will see a huge difference between the POIs data and the natural languages is because those tokenize the sentence basically based on a syntactic rules, which means that there's a natural orders in these natural languages. So But for POI datasets, there's no natural orders. So which means we have to construct the POI sequence, just same as this kind of tokenized sentence. So we use the spatial distribution. We consider the spatial distributions of the POIs to construct this POI sequence. So we can input that word to vector model. Imagine this is the this line in the straight. All the blocks refers to this POI point, and we can set a window size uh, to set a window size how many surrounding POIs we want to include in the training process. So we can use, for instance, we can include the two POIs, two POIs on the left and the two POIs on the right to predict the central POI class, which is the cafe. So this is the how the word to vector works, and eventually we will get a vector for the POI class. But in this study, we want to delineate the urban function, and so how can we do that? So we use the Doc2Vec model to realize that to get those kind of urban functions used in the cities. So the Doc2Vec model actually is an extension to Word2Vec model. You will see that this two graph. This is the Word2Vec model I showed before. This is the Doc2Vec model. The difference is that the Doc2Vec model got additional input here. This additional input in the natural language processing, it represented this is the paragraph ID, which means it represents the missing information from the current context. Because for different training sets, maybe maybe this tokenized sentence share the same paragraph ID. If we don't have this paragraph ID as the input, which means we ignore the context of this tokenized sentence. So eventually, so we need that this kind of this paragraph ID to act as a memory of this the context of this paragraph. So when we apply this model to the point of interest data, we can imagine the city as a huge document, and each district can be the paragraph, and this pointer refers the words in the document. So eventually, we not only have the vectors for the POI class, we can get a vector for those kind of for each district in the cities, which it include the information of the urban function they use, and this is how the Doc2Vec works. So in our case study, we choose London metropolitan areas, and we got around 420,000 POIs in the cities, and you see here they are in the classification for the POI datasets is a three-tier hierarchy classification. It includes 9 groups and 52 categories and around 600 classes. So when we, as I said before, the reason why people apply this natural language processing technology to the POI datasets is because we see the similarity between natural languages and the POI datasets. So if we plot the rank of the POI classes and plot the rank and the frequency for the POI classes, we'll see a distribution like this. This is similar to the natural language because only a small proportion of POIs appears in the cities more frequently. It's just like in the languages, you only use a small proportion of words compared to the total number of the dictionaries. So in London, you will see the first the top 1 POI class is the bus stop, and then it is the hair and beauty service and convenience stores, fast food outlets, and restaurants. It's surprising that the hair and beauty service come to the second position. I can't imagine Londoner leave during the lockdown. And when we took the logarithm for both rank and the frequency, you'll see that basically in most of part of this distribution follows a strict lines. This is similar as the Zipf's flaw we found in the natural languages. So I will talk about the specific method used in this case study. First, we will construct the POI sequence based on the human accessibility. So we can use this POI sequence as the input for Doc2Vec model. And more importantly, we have to tag the POI sequence with the spatial unit ID. So in the end, we not only got this vectors for POI class, we can also get a vector for a comprehensive vector for this spatial units. So this is how we construct the POI corps, basically POI sequences based on the human accessibility. Firstly, we generated random points along the road network. The reason why we do this is because if we generate the random points evenly in London, it will be problematic because the density of POIs in the inner London is quite different from the outer London. So with the road network, because the density of road network is quite similar with the density of POIs in the city. So we generated random points. The reason why we don't like use these points of POI data itself, because it will cost a lot of computation power, and to generate random points on the road network will save a lot of computation cost. So then for each random point, we search the accessible points POIs. We set a buffer around 200 meters. And then we calculate the Euclidean distance from the POIs to that random points. And then based on this distance, we can sort those POIs in a certain areas. We can get those kind of POI sequence, like a POI 1, 2, 3, and 2M. So the reason why we use Euclidean distance instead of those kind of network distance, because in such small areas, I don't think there's a big difference between that difference. And if you're interested in this topic, you can check this paper by Hua in 2018, talk about is that Euclidean distance that bad. So the second step is to tag the POI sequence with the spatial areas. So we can tag the POI sequence by the London Borough ID, by the London Ward ID, or by LSOA, or by traffic analysis zone. So how can we choose those kind of spatial units ID? So in previous studies, a lot of researchers use the traffic analysis zone. Some use the grades as the spatial units. The reason why we don't want to use the grades is because it's the same as it's a simple but I mentioned before, because the density of the London is quite different, and we decide to choose to use geostatistical spatial units like a super output areas. So here we select the lower layer super output areas, and we compare the different levels of the output areas, and you can see for the output areas is not like continuous, and for those MSOA, it's not sensitive. It's not sensitive to the is not that sensitive in terms of the diversity of the POIs. Oh, sorry, I should mention this is the density of the POIs in each in these spatial units. So this is a process for training the vectors for both the POI classes and the spatial units. And as you can see, we should input those POI sequence in the input layer, and we set the fixed size for this hidden layer. And during that process, we use weight matrix to convert those input POIs. And then we use the softmax functions to convert that scores to distributions. Then we can compare with the true labels. For instance, if this is this for this, for instance, if this are the surrounding POIs, and we select the central POIs, and we put it in the end as a true label. So in the end, we can use the cross entropies to compare the performance of these predictions, and then we can tune the models, the parameters in the whole models, and then we can eventually get those vectors to represent the POI class. So this is similar to this spatial units ID, and eventually we will get the vector representation for this LSOA units through this document matrix. So once we got this vectors for POI class, the interesting thing that we can do is once we vectorize the POIs, we can so-called calculate them in the vector space for two vectors. If we want to calculate the similarity, we can just calculate the cosine distance between two vectors, and then we got the similarity between the pair. Sorry about that. The pairs in the POI classes. Here the matrix we got. So basically we got around 600 multiplied 600 matrix, and for all the pairs between the POI classes, and we visualized it in much more dimensions, in the 3D dimensions. So which means we can, if we select this POI class, we can find all the similar POIs with this POI class, and you also get this similarity scores for those similar POIs. So as I said before, the Doc2Vec model not only provide the vector for the POI class, but also provide a vector for the whole spatial units, which means in this case is the vector for the LSOA. And with that, and we can use the k-means clustering to cluster these vectors for the LSOA spatial units, and then we got those functional areas in London metropolitan areas.
If you could just start rounding up, please, Haifeng.
Okay, so yeah, because this is a kind of unsupervised clustering. Although we we've identified areas of this urban functional use, but we have to know what the function inside that urban functional use areas. So we use the enrich factors, and to see the proportion of different POI groups in that clusters, so we can annotate those these clusters, those urban functional use clusters. So in the end, I would briefly talk about how we evaluate this model, and we use a random forest classifier, and the input is the feature we get from those Doc2Vec model, and also we got the features from the frequency-based frequency-based methods like term frequency, inverse document frequency, and the latent Dirichlet allocation. So, and we labeled it as a London output area classification, and so we will see this the performance of this prediction by this classifier. So the conclusion here is this study integrated the neural word embedding and the disaggregated data to delineate urban functional use following a bottom-up approach. And this Doc2Vector model compared to the Vogt2Vector model helps to vectorize the urban functional use for the spatial units while considering this spatial distribution of POI classes. And lastly, we provide an empirical case in London. And the future work we want to do is to, because the POI data sets in the cities keep updating, and we're trying to include this time series data of POIs in London and explore the dynamics of this urban functional use. And maybe we can develop a tool for policymaking in the context of the adaptive planning. Yeah. This is basically this presentation, and here the reference I mentioned in this paper, in this study. And here's my emails, and I would love to get feedback from you and any contact from you. Yeah, thank you.